Welcome to the pumpkin update. And this is a project, so this is a animated and sound pumpkin that I got from CostCo. Mostly because I like the shape and I thought I could do something interesting with it. So, as I talked about in the previous video, it has this light and sound system in it. It detects either motion or noise and then turns on and plays some spooky noises and does some really poor lighting with this single RGB LED. And I spent a little time in the last video looking at the circuit. I found that very nicely the big IC in the middle, when it turns on, it puts out 2.5 volts on one of the pins, which presumably drives the other circuitry, specifically the sound circuitry. So I thought I would drive my system off that. I attached a very fine wire to that, soldered it on, and right after that this whole thing stopped working. And I spent a little time trying to fix it, didn't have any luck, and kind of got tired of that. And I really didn't approach this in the first place for the spooky music side. I approached it more for the LED side. So we're going to take this and toss it away. So to move on to the LED side, I spent a little time, did this really ugly drawing of what the spots of the pumpkin look like. So we have 2 eyes, there's some spacing here, we have a nose, and what I essentially decided was I wanted LEDs for each of the eyes, LEDs for the nose, and then 5 LEDs for the mouth section, and that's what I wanted. But since I didn't want just a single LED per, I wanted a little more option. Partly to get a little more light, and partly because I thought I could do some animations in the eyes, kind of make them twinkle and stuff, and that was easier to do if I had multiple LEDs. So what I did was dig into one of my old projects. And this is the project. It's called the dodecahedral light engine. So basically, it's a dodecahedron, 12 faces, 3 LEDs per, and the LEDs are designed, the PCBs are designed so you can just solder across and get them to work this way. And this is used in my one of my Christmas displays. There are 12 globes. I have a globe. 12 globes that sit on top and then do different light things. So when I had the PCBs made, like usual, you can order a lot of PCBs, and I thought I might be able to sell a few of these. I did sell a few, but really not terribly exciting to most people, and they are a pain in the butt to do all the soldering on. So I have a fair number of those left. So what I decided to do was use one of these for each of my LED locations. So took that, set that aside, and one of the problems, I had to figure out how to mount them inside. And the obvious thing was to just use something flat, but the problem I have is that there's this small little hole in the back, and whatever I build has to fit in. And I thought about doing some wood pieces, some other pieces, and eventually I decided to do cardboard. So that's what it looks like. What I'm going to be able to do is, any luck, fold up the cardboard, fit it through that hole. I already tested that, and then go in and open it up, and then I'll hot glue it in place. So once I had that, I needed to start working on software and the driver circuit for that. So I have here, not surprisingly for me, an ESP32. This is a set that aren't really particularly high quality. The boards I've had some trouble with, but it seems that they are working okay, except for something very strange, that the ground pin down here is actually not the same as the ground pin up here. The circuit works fine when you're connected to this ground. If you connect to this ground down here, the thing won't even boot. It runs into EEPROM problems. So I presume that's just this being a cheap board. So, very simply, a few headers, female headers, one to grab ground, one to grab 5 volts, and then one to grab the data out for the system, for the LEDs. And then this worked fine. I could power it through the USB just to run simple stuff, but the problem is that you can't power fully through this USB simply because there's a little diode in these, and the diode keeps you from back feeding voltage through the USB and burning out your computer. But the diode gets really hot if you try to pull like an amp through. And these, the WS2812s pull 60 amps per, if you have them on a full white, something like that. And 1, 2, 3, 4, 5, 6, 7, 8. So we have 24 of them. 24 times 60 is about, well, you do the math, 1.2, probably 1.4 amps. Enough that I could easily burn out the chip on this, the diode on this, or overheat some of the other chips. My broken Node MCU, the ESP8266s, I've broken one or more boards doing that. So what we have is we have a run-of-the-mill USB power supply, a USB power cord, and then that feeds 5 volts into the LED section, and kind of interestingly back feeds 5 volts into the ESP. So what this means is I can either run the ESP directly connected, and it'll work as long as I don't pull too much power, or I can just plug in. I can just plug in the power supply, and it'll work fine. So, just a quick little demo. Let's see if this works. Plug in. And there we go. It's running a simple animation that I wrote. It's really a Larson scanner, but it looks a little weird because, you know, the Larson scanner is set up to do one LED at a time, and because these are together, it looks a little weird. But this was enough to check that everything worked, and that the burn-in, I burnt it in overnight to see if I could heat up the LEDs a little. I'll do a little more now that I have the full power here. I'll have a little more to do, probably a full burn-in on full white, so I can heat them up nicely. And then probably do that overnight, and then we'll put this inside the pumpkin, and we can start working on the animations for real. And I don't have great ideas there. We'll do something back and forth on that. We'll do eyes that kind of look similar, look solid, and then kind of sparkle or spin or something weird or change color. I don't really know what the animations are going to be like, but I guess we will find out along the way. That typically happens in these sort of projects for me. So that's the hardware. I'll be back looking at software. Here we are again with the pumpkin project, and I ran all of these full white for about 12 hours overnight, and they seem to do fine, which means I think they're going to last well enough inside the pumpkin. So let's put them in the pumpkin. I'm gonna have to set that aside. that, well, it's kind of backwards. I put it in so it was facing the back, which is kind of the foolish direction, I guess. Basic problem is to move everything around so it kind of fits where I want it. Still have the microprocessor approachable. So I didn't break anything. Here we have pumpkin. It's not doing any animation right now, but that looks pretty good from a light perspective. I'll have to flip and do some animations to see if I'm getting too much bleed. I may have to move it forward a little. How far back do I have it? Now it's actually reasonably close to the front right now, where I have that set. So that's putting it in, and the next step will be to write some animations and see what we get. Okay, so I got all the lights in, mounted on the cardboard, and put them in the pumpkin, and this is the result. And wow, that looks horrible. First, what you could notice, if you notice the eyes, well, first of all, they aren't even. They don't really get much light. The nose is kind of close, except the emitter kind of isn't in line with the nose. It's kind of up above. And then it doesn't really work for the mouth part either. You can see all the LEDs are too high, and they don't really follow the correct path that the mouth does. So I'm going to call this approach a fail, and I'm going to get in and try a different approach that I think might work a little better. So rather than going with a flat piece of cardboard, we're going to try going with more, I guess, tubular pieces. Maybe that's the right way to think about it. So what I'm going to do is build for the bottom essentially a box, kind of an open rectangular box. And the front of the box will be the shape of the mouth, and then I'll put it back in the box, and that's where the emitters are going to be. And do something similar for the nose and the eyes, and hopefully that can get me, the alignment I want and make this look a little better. So, failed experiment, but we learned something, so we'll go on and do the next thing. Here we have version 2 of the pumpkin insides. So I've got a light here and hope you can see pretty well. So what I did is I basically built a series of boxes. So there's the box around the smile, and it's a couple inches, maybe 3 inches deep. If we pan up with the light, there's a box around, a triangular box around the nose. And then finally we have an I1 over there, and we have an I1 over there. And this gives me consistent spacing and light control and location control. So that's what the inside looks like. And if we come over here, we can see the pieces that I've built. So this is the smile base plate, which is just a modification of the plate that I used before. I'm going to trim the bottom off a little bit. This is the nose plate, and then we have one eye and then the other eye. So these will just basically be put in there and attached to the boxes that I built inside. I'm thinking that it will actually be attached with tape. The boxes themselves are held in with hot glue, but I kind of want something that's less permanent holding the lights in, because otherwise I'm going to have to destroy it to tear it apart, and then I'd have to rebuild it. So that's the new arrangement. We'll come back when we actually have it lit up. Here we are, finally getting to the finished product on the pumpkin, and I want to talk about the animation, and we'll talk about the animation in the abstract rather than talking about it in code, at least initially. So I did a little PowerPoint presentation because I thought that would be just a nicer way to explain it. So here we have the pumpkin, and it has two roughly triangular eyes. And then inside, behind the eyes, there are there's a little board behind each eye with 3 independently addressable LEDs. So we can do whatever we want with each of the LEDs. And I played around with a bunch of different things, and this is the animation I came up with for the eyes. And what we'll do is we'll start with one of the LEDs in a specific color and the other 2 off. And we'll just cycle through the LEDs in order. So top one's red, bottom middle one's red, bottom outer one's red, and then back to top one red. So you can think it's kind of a rotation through the LEDs. And that's what one eye does. The other eye does the same thing, except in the opposite direction. So top, left bottom, right bottom, and then back to top. So you can think one goes clockwise, one goes counterclockwise. It's not really that evident which direction they're rotating, but that's what I chose to do. So they'll rotate a few times, and then the eye will switch, both eyes will switch to a different color at the same time, rotate some more, and they just keep cycling through that sort of thing. So that's what the eyes do. For the rest, we have the nose and the mouth. And I played around with a bunch of different animations here. Some were more rainbow based, some had things going back and forth, but I ended up deciding to do something pretty simple. So that's what the nose and the mouth kind of look like. And in the nose, we have another board, same board that has 3 LEDs, but we treat them as a single chunk of LEDs. They're always all the same color, rather than treating them as individual LEDs. So you can think of it kind of like it's one big LED, even though it's, from a code perspective, it's 3. And the animation that we do for this is pretty simple. We start with a color, and it kind of sits for a couple seconds. Then it blends from that color to a new color. We wait a few more seconds, and it blends to another color. So it just keeps cycling through different colors. And of course, there's one of those boards behind the nose, and then there are 5 individuals behind the mouth. That was kind of the coverage I thought I needed behind the mouth. And also, I thought I was going to do animations back and forth, but I decided not to, at least not for this version. Now, before we look at code, it helps to understand how the LEDs are numbered. So for the mouth and the nose, you can think of each of the boards of 3 LEDs has an individual number. I call them spots in the code. So you can think 0, 1, 2, 3, 4 are the mouth ones, and then the nose is number 5. I don't know if it's left to right or right to left. It doesn't really matter. You can treat the eyes as 6 or 7, or you could treat them with their individual numbers if you actually need to do individual LEDs, and that is actually something we need to do. So that is what the code looks like. That is what the animation, how the animation works, and that is how the numbers are assigned. So let's go look at the code. And here's the code. first of all, you'll note this doesn't look like a normal editor. And the whole goal of my system here is to make writing animations easier. So I've probably written, I don't know, 6 or 7 of these systems. In the past, every time I wrote one, I would do custom C++ code, and I came up with different ways of specifying the animations and different ways of making them work together. But it was painful to write the code, and then whenever I changed the code, it was painful to wait for it to modify and then download, and that meant that I had to have whatever I was programming back inside my office, rather than most of these are like Christmas or holiday decorations, so they need to be outside. So that turned into just a big pain in the butt. So this is what I've called the sequence controller. You can see it says Hack-A-Lantern. That's actually the name of this particular instance. So it's a ESP32 inside the Pumpkin. And because ESP32s do wireless, it is serving this web page back onto my Windows system. And you can see up here it has its own IP address. So it's on my wireless network. So what that means is I have a language that not only allows me to do things, I think, more efficiently and more clearly than in C or C++, I can easily modify it and just send it across to the microcontroller, and it just stores the new program, restarts, and keeps running. To be fair, it is possible to update ESPs over the air with C and C++ programs. I've elected not to do that, mostly because it still doesn't make writing the code any easier. It just makes update easier. So this is kind of the language, which I've called DIM, is kind of a combination of some basic constructs and some C constructs. I'm not sure it's going to stay looking like this, but that's the way it looks now. Can kind of start at the top. So config LED actually tells you. So it supports multiple LED strings. It also supports PWM at the same time, so you can do both. This says my first LED string is RGB. In this case, that means WS2812. It has 33 LEDs. That's actually not true. It only has 24, but that doesn't matter. And it's connected to pin 13 on the microcontroller. I'm going to skip these. And I'm going to skip that. We have a concept of colors by color number. That's just convenient to have when we're switching colors. And this basically takes a number from 0 to 5 and returns this little triplet, which is the RGB for that color number. So you can see 0 is red, 1 is yellow, 2 is green, and so on all the way through. So you notice the language supports variables in triplets. It also supports quad if you happen to have want to do something that has RGB and brightness as well. I don't use that yet, but it's possible. So let's move down. This, you can think of this code down here as the main function. You don't have to actually have a main. Maybe I'll switch that sometime, but you actually don't have a main. So basically what it's doing has a for loop here, and it sets main color number to a random number between 0 and 5. And if it's not the same, it goes off and does something. If not, it just keeps going around until it gets main color number to be different than the old one. And this is so that we don't do try to color blend from one color to the same color. It just doesn't look right. So we've got a new main color number, and you can think of main as pertaining to the nose and the mouth. We call a function called breathe and I spin, pass in 100, we'll talk about in a second, and the number. Okay, so here we are up in the function. Count is set to 100, and then we have the main color number. And remember I said in the animation that the color of the nose and the mouth would blend to a new color over about a second. And count is 100, and the base time in this animation system is 1/100th of a second, or 10 milliseconds. So it means if you're going to do something with a count of 100, it's going to take place over a second. So we have our first for loop, and spot is from 0 to 5. So this will refer to all of the mouth locations and the nose location. And then this is essentially an animation setup command. So over the next 100 cycles, or in this case 1 second, at a given spot, animate whatever the current color is to whatever this returns. So we created a new color, and this will return the RGB. This should probably be here instead. I only need to call it once. So basically we go through, and for all the mouth positions in the nose, we say over the next 100 cycles of animation, I want you to change to this color. Now, something that's really important to understand in this language, in this system, is that defining an animation is a separate step from executing an animation. And that's really important. You remember the animation I showed you, we want to be doing eye rotation at the same time we're doing something else. So all this chunk of code does is say, when you get around to doing animations, this is the way I want to animate these specific LEDs. It doesn't actually do any animation. So that's all the setup for the eyes and mouth. Now we need to go to the eyes. I mean the nose and mouth. Now we need to go to the eyes. And here we have another set of code. It's going to get the random color again and do the same thing to make sure it doesn't have the same color as before. And it's going to call eye rotate. And eye rotate is a function here. Not surprisingly, it makes the LEDs in the eye rotate. And I'm not going to go into the details of set specified LED to color, but basically this is how many cycles it will take. So 5 cycles, or 5/100ths of a second. This is the spot number. So the eyes are spot number 6 and spot number 7. Color is, not surprisingly, the color you want it to do. And then this final parameter is which LED in the spot you want to use. So I'm going to come in here. It's going to say left eye, set LED 0 in the left eye to this color. And it will also set LED 1 and LED 2 to black. So that's the first animation. So that's the left eye. And then the right eye, it does the same thing, except it sets not LED 0, but LED 2. And that's because the left eye is going to go 0, 1, 2, and the right eye is going to do 2, 1, 0, and that gives us the different directions in rotation. So we've set those two up, and then we call A, or animate. So we're going to animate through 5 cycles now. 5 cycles is long enough for these two to fully complete. So LED 0 and LED 2 will be fully on at that time. Also, remember that we also set up the animation for the nose and the mouth. So that will actually take 5 steps as well. It'll spend 5 cycles animating the nose and the mouth. Now those are set up to take a full second, so that's only, a small amount of animation there, but that'll do that. So that's first step, LED 0 and 2 on, then LED 1 and 1 on, and then LED 2 and 0 on. So you can see it's just you know, turning one LED on, turning the next one on, turning the next one on, and then just cycling through. So it's the same sort of rotational animation I showed in the PowerPoint. And it's going to do that 6 times. So what we can see is it's done that 6 times, and then that means each of them, it's done 15. 5 plus 5 plus 5 times 6 would be 90. So after it does that, most of the animation for the nose and the mouth will be finished. It's going to hop out of here, back to here, and then it's going to keep going. And get a new color, go back into eye rotate. So what you can see is that we're going to call eye rotate generally about 5 or 6 times, depending on how often this is true. But the first time it's going to do most of the nose and mouth animation, and it will finish up the second time. And then after that, there's no longer any defined animation for the nose and the mouth. And when there's no defined animation, there's nothing that the system does. So that is how we get that pause where the nose and the mouth just stay the same color. And then eventually, we'll get through this for loop. We'll hop back out to main, and the main will come around. We'll get a new main color, and that'll be a new color for the nose and the mouth. Hop back in. So basically what we're doing is we're always spinning the eyes, and we set up every once in a while, we set up an animation for the nose and mouth. And that's the total thing. And then up here, this is the one that sets the LEDs for the specified LED in the eye. And then these are just kind of helpers that make it easy to set all of the colors in a single spot, all 3 LEDs to a single thing. So that's all the code is, and that's really pretty short. So, I'm sure you didn't come here just to see code. Here, now flipping over to my other camera, this is the live pumpkin. And I'm pretty happy with that. So what you see the eyes are always spinning. I think looking at it for real, you can kind of see that they go in different directions. It's a little harder to see in the camera. And then you see right there, we just saw a switch of the mouth. Wait a couple seconds. Switch of the mouth. Wait a couple seconds. Switch of the mouth. That wasn't a very good one. Violet to cyan. Switch of the mouth, back to red. And then that just keeps running and running. So originally I'd planned on multiple animations, but I kind of like this one so much, I've decided we're just going to stick with that. But the nice part is, obviously, because I'm using my new system here that can be updated remotely, if I actually want to change things, I can just plug it back in, wait for it to connect to the network, and then just play around and put a new code there. Put some new code there. So that is the end of the pumpkin. Hope you enjoyed it.